Today we're doing the ninth set of notes, and this is on the binomial theorem. So this is actually not required in our curriculum, but I think this is something good to expose you to, and I think you'll find that this is a relatively interesting lesson. So we're going to be using something called the Pascal's triangle, and I want you to take a moment and I want you to look and see if you can kind of notice a pattern. So now in row 0 I have 1. In row 1 I have 1, 1. In row 2 I have 1, 2, 1. And then I have 1, 3, 3, 1, and so on. So if you kind of notice, Pascal's triangle is based on the row above it. So the way that I got this 2, for example, is adding 1 and 1. The way I got this 3 is by adding the 1 and the 2. Similarly, the way they got 4 is 1 and 3. The way I get 6 is 3 and 3. So we're going to try rows 5, 6, 7, and 8. So again, don't write too large so you can fill this in. And so you start with a 1. Let me change this real quick actually. So I start with a 1. And then 1 and 4 gives me 5. 4 and 6 gives me 10. 10, 5, and a 1. Row 6, again we start with a 1. 1 and 5 I get 6. 15, 20, 15, 6, and 1. Then row 7, I get 1, 7, 21, 35, and then we go back down. 35, 21, 7, and a 1. And then the last row, 8, we have 1, 8, 28, let's see, 46. And then we go back down. No, we don't. I lied. We have 70 here. Now we go back down to 40. And by 46, I mean 56 there. And then 28, 8, and a 1. Okay, so again, there's several patterns. If you notice, like through the second row, I go 1, 2, 3, 4, 5, 6, 7, 8. And then the next row I go, so here I go up by 2, then I go up by 3, then I go up by 4, I go up by 5, and so on. So there's several patterns and ways that you can look at this to kind of determine that. So I'm going to show you how to use Pascal's triangle now. So we use Pascal's triangle if I'm trying to expand binomials. So obviously we've done some problems where we've had to multiply or FOIL something out 3 times. So once it gets up to like the 5th or 6th power, it becomes quite cumbersome. So instead of doing that, we use this formula. So your coefficients right here are coming from the Pascal's row. So if my n is a 5, if I'm raising it to the 5th power, I'm using the coefficients from the 5th row. And then we kind of alternate. If it's n is 5, I start with my first term being raised to the 5th power, the 4th, 3rd, and so on, and I downgrade it. Whereas your second term, b, starts with x1 of 0, and then it works its way up. So, and again, this looks a little confusing looking at it like that. When we do the next problem, it'll kind of make sense here. So here I have a plus b raised to the 6th power. So we're going to take a moment and write down the values from the 6th power. So I have 1, 6, 15, 20, 15, 6, and a 1. Alright, so now we're going to apply this. So my first term is going to be 1a to the 6th power plus 6. A gets bumped down a degree, and now I introduce b into the mix. Plus 15, again a gets bumped down to the 4th, b gets bumped up. Then I have 20, a gets bumped up, bumped down, b goes up. And then I have 15a squared, b to the 4th plus 6ab to the 5th, and then I am with b to the 6th power. So if you were to multiply a plus b out 6 times, this is the answer that you would get. This is supposed to just be a shortcut to that method. So go ahead and pause your video. You're going to try letter B. When you're ready, hit play. We're going to do some on the back. So on the back, I have 3x minus 2 to the 5th power. So now that we have the understanding on how to set it up, now we're going to show you how to kind of expand it a little bit farther, because it's not always just going to be a and b. So first thing I need is the row from the 5th row, the coefficient. So I'm going to pause the video and I'll write it down. Alright, and a is 3x and b is negative 2. So for my first term, my coefficient's 1, and then I have 3x raised to the 5th power, no b, plus 5, because that's my coefficient. 3x is now going to be raised to the 4th power. B is raised to the 1st power. 10 for the next coefficient. 3x raised to the 3rd. Negative 2 raised to the 2nd. 10 again. 3x to the 2nd. And negative 2 to the 3rd. Plus 5. 3x to the 1st power, negative 2 to the 4th power, and then I end with just my b value, negative 2, raised to the 5th power. So now we have to simplify this a little bit. So I need to find what 3 is to the 5th power. So I get 243x to the 5th. So 3 to the 4th power is 81. Then I have to times that by 5. Then I have to times that by negative 2. So I get a negative 810. So it's actually going to be minus 810 x to the 4th. Plus, so my next one, I have 3 cubed, which is 27, times 10, and negative 2 squared is 4, so I have to times that answer by 4. So I get 1080, and x is raised to the 3rd power. Plus, okay, so my next one, 3 squared is 9, negative 2 cubed is negative 8, so 9 times the negative 8 is negative 72, times 10 is negative 720, so we're actually going to be minusing. And my x is raised to the 2nd power. Plus, so negative 2 raised to the 4th power is 16, times 3 times 5 is 240, and I'm at a regular x now. And then negative 2 raised to the 5th power is a negative 32. So here is our final answer. So again, if you were to multiply this binomial out 5 times, this is the answer you would get. So yeah, it still takes a little bit of time, but I promise you it is much easier than multiplying that out 5 times. So I'd like you to skip letter B, and I want you to try letter C in your notes, and then we'll try letter B tomorrow in class. All right, so that's all for today.